Okay, I'm going to go over a few of these questions that were the ones that were most requested. And number 15 is one of them. So aluminum plus sulfuric acid yields aluminum sulfate plus hydrogen. So I'm going to need you to bear with me a little bit. The hotkeys don't work real well. So I'm going to need to be able to make subscripts and that sort of thing. So just bear with me. All right, so we'll start out here with aluminum. So aluminum is simply Al. Sulfuric acid, you can look that up, of course. On page 104 is where we learned all about naming acids, and this is probably time where it's time to start memorizing some of these. So sulfuric acid happens to be H2SO4. And if you're not interested in actually memorizing them, you can memorize the rules if you'd like about naming them so that you can come up with the proper names every time. Okay, I'm going to write yields just to simplify and not worry about getting that arrow in there. Aluminum sulfate. So I look up aluminum sulfate on the ion sheet of aluminum and sulfate. Aluminum's a +3. Sulfate is a -2. And so to get that net charge of 0 on the overall ionic compound, I'll end up with aluminum. I'll have 2 of those. And I will have a quantity 3 of the sulfates. Okay, my other product is hydrogen, and remember hydrogen when it appears as itself is always referring to molecular hydrogen. It's a Brinkelhoff, and so it'll be H2. Okay, so now going about balancing these, I find that one of the things that's the easiest is to take a look at these polyatomic ions and see if they transferred as a whole unit, which they often will. So notice how I've got sulfate here on the right, SO4, and I also have SO4 over here on the left in the reactants. Only I have a quantity 3 here on the right, but I only have a quantity 1 over here on the left. So I'm going to start out here by putting a coefficient of a 3 in front of my sulfuric acid. And then I'm going to take a look at the aluminum next, and I see that there are 2 aluminums. So I'm going to head over here to the left and put a 2, because aluminum just appears by itself. So now the aluminums are good, and the sulfates are all balanced out. So what's left are these hydrogens here. And I can see I have 6 hydrogens over here on the left side, but I only have 2 over here on the right. And so I can simply put a coefficient of a 3 here in front of the hydrogen, and now this equation is balanced. Let's go take a look at another one. Another one that was commonly requested was question 27. Mercuric hydroxide plus phosphoric acid yields mercuric phosphate plus water. Well, I'm seeing a theme. Looks like it was these acid ones that made it challenging for us. Okay, so let's start off with mercuric hydroxide, and I get to see that I've got Hg, and for mercury with that +2 charge, the mercuric form, and hydroxide is a -1, so I'll have my hydroxide with a quantity 2 of those to make that net charge of 0. Okay, my phosphoric acid. So phosphoric acid happens to be H3 PO4, and I'll just leave it as that because that is the formula for it. And I wouldn't use the ion sheet. I would have been using the naming conventions for acids for that, or I'd need to go look it up. Okay, I'm going to use the yields again just to make it easier. Now I'm looking at mercuric phosphate, and I can use my ion sheet for that. Phosphate, remember, has a charge of -3, but the mercuric part had a +2 charge. So to get my net charge of 0 on this compound, I'm going to end up with Hg, 3 of those Hg ions, and I will need to have 2 phosphate ions. So I was using that concept again of the least common multiple. Oops. Okay, and so my other product is water, so I'll add that on now. Get that subscript going. Okay, so now again, I really like using that technique of looking to see if the polyatomic ion, I can see it and find it on both sides. So sure enough, I see the phosphate ion here, and I've got two of them. On the left side, on the reactants, I only have one. So I'm going to start out here by putting a 2 in front. And that, now I have two phosphates on both sides of the arrow, if you will. Next, I'm going to take a look at that mercury. So I've got 3 mercuries on the product side, and I only have 1 here on the reactant side. So I'm going to try with a 3 coefficient. All right, so now it's a little bit messy because I can see these hydroxides, and I see some water, what looks like some hydrogens and oxygens over on the right. Now, what don't get confused about is don't mess with these oxygens over here. You already dealt with the phosphates, so those are good. Those oxygens are all balanced. You don't need to worry about those. So I'm going to take a peek at how many hydrogens I have on the left side, on the reactant side at this point. So I've got 2 when quantity 3, so that's 6, and I have 6 more right here. So that is a total of 12. So let me put a coefficient of a 6 here in the front, and I am going to hope that that works out with the oxygen. So I've got a total of 6 oxygens here. And sure enough, here's my 2 oxygens, quantity 3, so that's 6 oxygens right there. So I have now a nicely balanced equation. All right, the last one I'm going to take a look at is number 29. And again, it's got some acids in it, so I'm thinking that that was our challenge of the day, was remembering the formulas for some of the acids. So let's take a look at this one. So calcium chloride. So calcium's a +2 ion, and chloride is a -1 ion. So that would be CaCl2. And I'm going to have my nitric acid. So plus nitric acid is HNO3. Again, you could look that up. Didn't want to do that. All right, I'm going to go with yields again just to clean things up. Oh, wouldn't you know? Calcium nitrate. So calcium, again, a +2 ion. Nitrate's a -1 ion, -1 ion. So I'm going to have a quantity 2 of those nitrates to make a net charge 0 ionic compound. And then I have hydrochloric acid, and hydrochloric acid is HCl. Okay, so again, I'm going to use that technique I used before about looking for those polyatomic ions that show up in on both the left and the right, and to treat them as a single unit, like as a single variable. So here's my nitrates, but I've got 2 of them on the right. So I'm going to put a 2 over here on the left in front of HNO3, since I only had 1 of those. Calcium, I've got 1 calcium on the left and 1 calcium on the right. And so now I'm going to take a look at, I've got my 2 hydrogens and I've got 2 chlorines. So there we go. I'm going to put a 2 there, and voila, it's balanced. Be sure to send me some comments if you are unsure in Schoology some more. I can maybe give you some other tips or some suggestions. All right, thanks so much.